Hey again everyone. On the bench today we have another Kenwood VFO 230, and I've already done a video on one of these, so most of the time I wouldn't do a second video. You know, it's pretty much standard process on any of these that you go to, but I thought it'd be interesting just to take a look at this one and see if it has the same issue as the previous 230 we worked on. So I figured we'd go ahead and power it up and just check and see, and then have a look at the circuit boards and find out just what's going on. So I have the power supply connected to the 9-volt pin on the back. Haven't turned it on yet. I have it plugged into the AC mains. Now you know these have no power switches on it. So I'll go ahead and turn the AC main on. Then we'll turn the 9 volts on. And when you see it first comes up, it has a bunch of garbage on the screen. Now the reason why I powered it up like this, like I say, this doesn't have a power switch, and they're always plugged in to AC. And what turns this on is when you turn the TS830 rig on, it sends 9 volts and powers the system up. So all I'm going to do is just turn the AC off. You see the VFO light is still on. That's because the 9 volts is still active. And then we'll turn the AC back on. Now the display looks like it should. And then when you turn the VFO knob, you can see it starts counting up. What we're mainly focusing on is the output to a frequency counter to make sure that it is traveling through its selected frequency range. But one of the main problems is turning that 9 volts off and on, and that throws garbage on the screen. And just to verify this again, I'll turn the AC voltage on. Wait a second, then we'll turn the DC power supply on, and you can see there is garbage on the screen. Turn the AC off, turn it back on, we're back to 0, 0. Again, like I said, this is a design issue with this piece of equipment. As you can see right here in the VFO 230 manual, there's a note, and it says, if the VFO 230 frequency display is abnormal, disconnect the AC power cable, and after around 1 minute reconnect it. The display shows 0, 0 and the VFO starts correct operation. So as you can see, that is a design flaw. Normally what should happen in this situation is the 9 volts should come on, and then the AC power should be applied. But it's completely backwards than this, and that just throws the CPU for a loop when it's done like that. Now this problem could be eliminated if you could go in, and there's plenty of room inside the VFO to do this. You see our 9 volts right here. It's connected to pin 3 of this connected on the back of the rig. Now if you could take something that would, if you could build a board that has a sense line, so that when it sees that 9 volts, it could go to a delay unit with a relay, and you would just have to cut the 2 AC main lines and put a relay there, and then have a module that when it senses the 9 volts, that it would wait a couple of seconds and then energize the relay, thus turning the AC on to power the rest of the unit. And that would pretty much correct this failure problem. I mean, a lot of times, you know, you got equipment hooked up on the bench, the AC power line is back somewhere where it's not that easily to, you know, to get to, and you have to reach back there and unplug the AC power and then plug it back in. Another thing you could do if you wanted to do it manually is come on the back of the unit and put a switch, a manual toggle switch, to actually cut the AC off and on. I think the idea of building a board with a delay relay would solve the problem, and I may do that down the road. I'll have to think about that and look at it, but I believe that would be the best way. You turn your rig on, it sends the 9 volts to the VFO. Your timer or delay circuit, kind of like a soft start, would detect the 9 volts present and then turn the AC on. Once you cut the rig off, it would disconnect the AC. Alright, so I thought I'd go ahead and crack the unit open and we'll go ahead and start taking a look at it. One thing I did notice when I was turning the VFO a moment ago, I heard some rubbing on the VFO dial, and when I looked, we could see this front panel is loose. Now, it's supposed to be tabs around here that go under certain screws, like this top screw, and holds this in place. And I'm looking in here, I'm not seeing any tabs at all. So I'm going to go ahead and get this thing opened up and we'll take a look inside. And sure enough, as I thought, looking at this, you can see right here there is no plastic tab over here. That's broke off and gone. Didn't even see it. I mean, shook the unit around, and so I imagine all the rest of them are broken and gone too. So we'll have to look at, see if we can figure out a way to fix that. Another thing too, without this being down, if you screw this screwed in, you're actually pushing the top down further than what it's supposed to go, so it won't be flush with the outside of the bezel. Well, not quite flush. It should be a little bump there, but not like it was. So we'll have to look at that. I want to probably go ahead and pull out this main board so we can get down here to this encoder. Remember in our other 230 video, that's where we found the problem, was down at the encoder. There was horrible solder joints down there that was causing some more erratic display problems. So we'll get on there and we'll take a look at that also. But I'm going to go ahead and pull this main board out, and all we're going to do is start by removing these ribbon cables. Try not to grab the wires and pull it out. Try to grab the connector. You see that you can't get the your fingers on the connector that good. Two little needle nose pliers and they pop right off. Especially on this larger one here. Yeah. All I need to do is remove the 6 screws and the display unit should come right out. And we've had some funky weather. It was in the 80s, high 80s yesterday. Last night it turned cool on us again, and it was down in the 60s this morning. It's just up and down. This weather changes like this, it tears my allergies up. Okay, we should be able to slide this board right out now. And there we have it. I'm going to pull this front faceplate off. Set the VFO nozzle here to the side and get this set screw. And when you're taking this off, be very careful because your knob's going to come off and your outer plate's going to come off. Then you're going to have a washer, a spring, and down here will be another washer. You don't want to lose these. We should be able to pull these two knobs right off. You don't have to worry about the position of where to put this one because it's got a D hole in it. And this one, just leave it on one, put it back on one. And with this broken, it's probably going to slide right off. And sure enough, you can see the tab here. And part of that tab is still there. This tab is gone and the top tab is gone. And to get the encoder out, we'll just loosen up this nut and we can slide the encoder right out. I have the encoder out and I'm looking at it, and it is not as bad as the other 230 we worked on. Probably not going to be able to get zoomed in too good on it, but before we had, you know, some bad solder joints around the optical pickups, but this time I'm not seeing that. They look pretty good. They are a bit dry looking, but right here there's a transistor that's soldered in, and two pins on it has some cracks around it, and then this ground pin over here doesn't look that great neither, but it's nothing like the other one we worked on. It's a little different. Okay, I went ahead and soldered up all the funky looking joints, and what I did was just got the desoldering tool and removed all the old solder, applied some flux, and then resoldered it. Now we can clean up the flux residue, and we'll get this part here back reinstalled. Okay, I got the encoder back installed. I went ahead and removed the circuit board from it, pulled this little C-clip out and slid the shaft out. Went ahead and cleaned and lubed that, put it back together so yeah, that spins free. I went ahead and cleaned these other switches that I could get to and make sure they looked alright. But now we want to go ahead and take a look at the main board, see if we see any problems on it. So I'm looking at the bottom of the main board, and under the VFD I see some flux over here on this side, and over here there's none, and there's two pins right here on the middle that have no solder at all on one side and just a little bit on the other side. So something funky's been going on here. I'll have to take a closer look under the microscope and clean this up and resolder those traces. But one thing that really got my attention, I can get the camera to focus. This is the bottom side of IC1, and IC1 is a UPD 8048C. This is an NMOS micro 64 by 8 RAM, and I'm seeing flux all over the place, and I'm not seeing it on the rest of the board, but there's flux all over these pins, and here and here and on this side there's looks like white corrosion on those pins. So we might need to have to clean this up and resolder those, reflow those pins. Now looking here under the microscope, you can see the corrosion around this pin. This is pin 1. You can also see quite a bit of it around pin 4. And then up here around pin 6, you can see more of it also. It looks like somebody has been under here and has pulled this chip. You can see the corrosion there. Here on this side. Yeah, so we're going to have to get this cleaned up and see if we can get rid of this corrosion that we have on this. Okay, got all this corrosion off. Went ahead and just sucked out the IC and cleaned the board up and put it back in and resoldered it. And looking at it, I'm wondering about the type of solder that was used around that chip. I'm not sure if they use rosin core or not. It almost like they had, well, it looked like it might have been acid core sorta. But anyway, we got all that taken care of and got the VFD soldered back in like it's supposed to be. I'm gonna tell you one thing I really need to invest in, and that is a ultrasonic cleaner that will hold boards this size. I have a little small pot for little small things, but I really need to invest in one that's big enough to hold a board this size, because I'm gonna tell you what, this rosin and flux that was on this board, I tried to take it off my normal way. Usually I use a light acetone, put it on it, brush it off, wash it down, but that stuff was horrible. And if I had a good ultrasonic cleaner, I could stick a board in like this in and don't have to worry about it as bad. It took some time to get this board back clean. Anyway, I can go ahead and get this reinstalled, but we want to take a look at something else first. As I said before, it'd be nice to have a way to turn the AC off and on this unit, so that the user doesn't have to reach around and find his cord and unplug it. Again, the best way was to be able to come up with a delay circuit for the AC, but maybe we'll do a video on that sometime in the future. We'll sit down and design that. Right now I'm just not going to do it. I would love to, but that involves quite a bit of time that I don't have. So to make it easier, I believe we already have something that we can utilize in this piece of equipment without having to modify the chassis and drill holes and this and that. And that is this voltage selector switch. It's set for 120, and you see you can't move it over because of this little plastic tang to put it on 220 volts. Since the user has this in The US we use the 120 volt side. So we could actually rewire this switch to handle the AC current. And looking at this switch, I see no problems why it cannot handle it. In fact, you know, it's able to handle 220 volts through it. So we can actually use this as an off-on switch. Now we're on the 120 volt side. And as you can see here, that would be, all we need to do is tie this yellow wire and this red wire together, and that would keep the transformer at 120 volts all the time. This green lead is for 230 volts, so we can disconnect it and put a piece of heat shrink on it and tuck it down and tie wrap it. None of these wires are tie wrapped anyway, so we could do that with those. And I think that would be an easy way to put an on-off switch on this piece of equipment. I think what I'll do is just completely remove the yellow wire. It's just a bare wire with a piece of yellow spaghetti coating on it. We'll just move it completely. Then we'll take the red wire, bring it down and connect it to this terminal. Then we'll disconnect this green wire and heat shrink it, bring it down and tie wrap it. Then what we can do, we can come up here and bring one of the wires up to this side and then back down to where it's supposed to go. This way it'll put us an AC switch right here at the unit. Now it would be nice to have it on the front of this unit, but no simple modifications to do that the way the switches are laid out. Okay, I removed all the wires from the switch. Since the green wire is the 230 volt input, I have heat shrinked over the end of it so it can't short out anything. Now once I'm finished and tidy up these wires, I'll just bring this around and tie wrap it to some of the other wires. I have the yellow wire here, and what we'll do is we'll disconnect it from here. We'll snake this red wire under all this and tie it directly to this terminal. Now for the AC, putting this switch in it, you know, you always want the fuse closest to the power source. So you see the AC line comes in to the back of the fuse, and here on the other side of the fuse is a little inductor. We'll disconnect it from this terminal tie strip down here, and we'll bring it up right to the center of the switch. We'll then run a wire from this side of the switch back down and reconnect to this terminal where the white wire is, which is the input of the transformer. Okay, our power switch conversion is done. I reused the yellow wire to come back to the switch to make the circuit back down to the input of the transformer. And also I put a label on the back for off and on. This went directly over the other decal that's in there. Now if this ever wants to be put back to stock, you just simply remove this and rewire the switch back like it was originally and ship it off overseas to be used. But this way, this gives the owner a way to reset the AC power without having to chase down the end of the cord, which could be, you know, depending on how you have your setup. A lot of power cords sometimes are hard to get to because they're going to be behind a cabinet or built-in display shelf or however, you know, it's set up. Alright, the Kenwood VFO 230 is all back together. I went ahead and checked the output on the frequency counter and it's fine. And at the moment it's in its abnormal state as shown before, but this time without having to track down the end of the power cord, we just simply reach to the back, turn the power off, turn it back on, and we have our correct display. Like I say, the automatic delay would be a lot better, and I am planning on designing that in the future, but you know, again, it takes time to sit down and do that. So simple, quick little video, just showing one of the main faults. I went in, I got the front panel back mounted correctly. I put 2 pieces of plastic in there and heated it to it, and it was just some little clear sheets of plastic I had, and I cut them to size and drilled them out and put them on so that holds the front panel back in place. And with that, I think that comes to a conclusion on the repair of this Kenwood VFO 230. So you know, if you enjoyed the video, leave your comments down below. Always love to hear from you. You know, one thing I always used to say is that if people are going to take the time to comment on a video, I'm going to at least try to comment back. Now I've got comments out there that are over a month old that I haven't had time to reply back to, and you know, I apologize for that. Emails are still out the roof, 1,000 a week or so. It's just impossible to get to everybody, but I do want to say I try to read everything that comes in, you know, especially through YouTube, and I read through the emails the best I can. Anyway, again, hope you enjoyed it, and we'll see you in the next video. Bye now.